Hello, this is our first unit for Science 6. The first unit we are looking at is called Air and Aerodynamics. Our first topic today is properties of air. Alright, so first, what is air? So you probably know air is all around us, it's invisible, it surrounds the earth. It's mainly a mixture of oxygen and nitrogen, and it's also a fluid. So gases and liquids are both fluids. And so air is made up of different air particles, and they are loosely held together in this gas form. So keep in mind that any fluid will be is any substance that will flow. So this includes air as well as gases as well as liquids. All right, so air therefore is a fluid because gas can flow in our atmosphere. Now we're going to look at the 6 properties of air that allow flight to be possible because objects and animals are able to fly through the air. So there's 6 properties we're going to talk about. The first one is that air takes up space. All right, so for example, if you blow up a balloon, the balloon starts to expand, therefore air takes up space. Number 2, air also has weight or mass. So if you blow up a balloon, it will actually be heavier than an empty balloon. Number 3, air is affected by heat. So air particles that are heated, they are going to move faster, and air particles that are cooled, they will move slower. Number 4, air exerts pressure. So air will exert a force in all directions on an object. Number 5, air can be compressed. So air particles, they have spaces between them. Therefore, they can be squeezed together. That's what compressed means. And number 6, air is affected by altitude. So altitude means going up in, for example, climbing a mountain, you are increasing your altitude. So as you go up a mountain, for example, mountain climbing, there is lower air pressure the higher that you go up. All right, so just again, the 6 properties of air. Air takes up space, air has mass or weight, air is affected by heat, air exerts pressure, air can be compressed, and air is affected by altitude. All right, so here in this example of air takes up space, if you take, for example, an empty Ziploc bag, open it up, and you pull it through the air like a parachute, you close it up, you seal it, and you try to squish the bag, that bag is full of air. And you can also do this by blowing up a balloon. That balloon expands because you're putting something into the balloon. You're putting air into the balloon. So therefore, air takes up space. The more air you put into the balloon, the more space it's going to take up. If you use a pump, for example, to blow up a basketball or a football, you're putting air into it, and that air is taking up space. That is why the football expands. Air has mass. We'll take a look at a video that's showing this as well, but if you take an empty balloon and you weigh it, take that same balloon, inflate it, then you weigh that balloon, it's going to weigh more than the empty balloon. You can also hang balloons on a hanger like this, and the one that is filled up with air, it will be heavier. Air exerts pressure. So let's take a look at this quick video here on how air exerts pressure. So next, the next property of air is affected by temperature. So remember that if you heat up particles of air, they will start to move faster. And if you cool down particles of air, they will move slower. All right, so here in this first picture, temperature inside and outside the balloon is equal, so the air pressure is the same. The air pressure inside and outside the balloon is the exact same, so there's no change. Then the air inside the balloon is heated, therefore the air pressure increases, and therefore the air will now spread out and it will now push against the sides of the balloon. So now the air pressure inside the balloon is not equal to the outside. So therefore the balloon will expand until the pressure inside the balloon is the same as the pressure outside. And then in this last picture, the air is cooled. That's going to decrease the pressure. The balloon will shrink until the temperature or pressure inside the balloon is now equal to the temperature outside. Air can be compressed. You can do a quick experiment at home as well. If you have a plastic bottle, take the cap off the bottle and hold your hand above the mouth of the bottle and squeeze. Next, you can screw the cap on tightly, squeeze again, and you'll see the two different observations. You can also then fill that bottle completely with water, put on the cap and squeeze again, and then see what happens then. All right, so when you squeeze the open bottle, you're forcing air out of the mouth. When you put the cap on the bottle and squeeze again, there's no place for the air to go, but you were able to squeeze the bottle together. So basically you're able to compress or squeeze together the air inside the bottle. When you fill the bottle with water and then you put the cap on it, you can't squeeze the bottle very much because you can't compress the water that's inside. All right, so gases like air, you can compress them, but liquids like water are not compressible. And then we talked about how air is affected by altitude. The higher you are, the lower the air pressure. So if you're up at the top of a mountain, there's way less air pressure. So people that are mountain climbing, they have to use oxygen tanks because the air that's outside is too thin for them to breathe normally. And that's because human bodies were used to air pressure. The air pressure in our lungs, in our ears, in our stomachs is the same as the air pressure outside of our bodies, right? That's what makes sure that we don't get crushed. Our bodies are also very flexible to cope with any changes in inside and outside pressures. When you go on an airplane, they have pressurized cabins to compensate for that lower air pressure at high altitudes. Yeah, so here in this picture we can see lower pressure, less particles, and down here we've got higher pressure, we've got a lot more particles. All right, gases in the air. So this here is just showing what the air is comprised of. So the air around us is a mixture of different gases, mainly nitrogen and oxygen. Nitrogen is shown by N2, oxygen is O2. There's also small amounts of argon, which is shown by Ar. Carbon dioxide, which is CO2. Neon, Ne. Helium, He. Methane is CH4. Krypton is Kr. And hydrogen is shown by H2. Okay, evidence of gases in the air. So basically, what evidence do we have that there are gases in the air? So one method is if you light a fire, we can tell what gases are feeding the fire based on the color of the flame. All fires, they need fuel, and it's oxygen that is the main fuel source for a fire. And some gases are more efficient sources of fuel for a flame. So if we burn methane, carbon dioxide, and oxygen, the flame turns blue. A blue flame is the hottest fire, which means it's the best flame for heating homes or cooking with. A yellow, orange, or red flame means the fire is not as hot, and then the coolest flame is yellow, and it means the fire is not getting enough oxygen. Nitrogen, which we talked about is in the air, is non-flammable, which means it does not burn. If we started a fire with a helium gas source, the flame would actually turn a cool neon blue color.